Okay, good morning to all remote centers. So in this session, we are going to learn about the signal processing, some commands and toolboxes using SCILAB, and also some commands on filters, digital filters and analog filters. So I suppose that everybody who is presenting, who is participating this course, you must have knowledge about some basic knowledge about the signal processing. So signal processing is a very core area. Without signal processing, you cannot think of anything, any equipment or any devices can work without signal processing nowadays. It can be the analog signal or digital signal, as we know, but definitely we will be concentrating on the digital signal only. So to start with, there are various types of signals. One is your one-dimensional signal, and it is a function of a single independent variable. For example, the speech signal, it is a one-dimensional signal with time. Two-dimensional signal that represents the signal with two independent variables, for example, an image, and it is the representation of an image can be done with the help of two-dimensional variable, that is with the pixels, that is x and y. Multi-dimensional signal is a function of more than two variables. So, for example, the video signal is an example of the multidimensional signal. So, the signal, whatever we generate from a source, that can be generated from the single source or the multiple sources. If we generate the signal from a single source, that we say that it is a scalar signal, and if the signal is generated from a multiple sources, we say that is a vector signal. Now, in case of SCILAB, just like as your MATLAB, you can work with vector signal, vector also, scalar also, and matrix also. So, for example, this is a very simple example to create a random signal. So we are taking the random signal, that is our RAND function. So it may be 1 to 10, it may be 1 to 20, any random values from 1 to 20, and each and every time you will get the different values. Random signal is important in case of when we do the neural network applications where the weights are assigned randomly first of all the weights are assigned randomly. That time we use this random function to assign the weights into the weight matrix. Otherwise, the random signal generation is not so much important, because whenever we talk about the signal processing, nearly unit step signal, impulse signal, or ramp signal, or the exponential signal, those signals are generally used. But anyway, let us see that how to generate the random signal. This is just random 1 to 10. You must have done the subplot command. So subplot, that is a 2 to 1, that means there will be 2 rows and the 2 columns, and we will generate the first wave, that is random signal, into the first quadrant. After that, random 1 to 20, next we have given 1 to 15, next we have given 1 to 25, and we have generated some random signals in the plots. Now, you must have done the GCA command also. GCA command is basically, I just want to tell within one example. GCA is your graphics handler. This is required in case of the SCILAB programming if you want to manipulate your graphics area of the graph. Graphics area means if you want to change, the X label, if you want to change the axis, if you want to change the legend plot, if you want to change the, the title plot, if you want to change the font size and all, if you want to change the location of the title. So all these are possible if you enter the handler in your Scilab programming. So what we have done here, that is t equal to 1 to 50, that is your just a range from 1 to 50 points. Then y is equal to random function from 1 to 50, and plot t and y. This is a simple plot, but after that we had done that x location should be equal in the middle. That is a is equal to GCA. That means a is a handler, GCA is a function, and a is a type of the object of that class or handler. Then a dot x location is equal to middle, a dot parent dot background. That means you are changing the background color of that. And after that you have taken that x title is equal to my title and my axis and volume. Just 1 minute to ask, is there any Scilab here? Yes, it is there. Okay, fine. So we can just check it that if this program we write in the Scilab, then what will be the effect? After that also we can do it. I'll just tell about the command. You can just note down in the command. After that we will make, you know, some 10 to 15 minutes will take. Then we will use all these commands in the Scilab, and you can also try in that period in your laptop. So let me finish up first. After that we will try the practicals. So this is your just how to use the GCA command and all. Finally, the signal generation. As I have told you that random signal we have generated, similarly you can generate the signal waveform also. So that you have already done. Y is equal to sine twice pi ft and subplot command and there. So GCA again we have given because we are changing the x label text and y label text and also the title. Similarly, we have done the sine wave and the cosine wave transformation on the generation. Next, let us come, that is up to the analog signal, just a beginning, that is analog signal. After that, we have done that sampling. If we have got the analog signal, how to do the quantization and how to get the digital signal, right? How we will convert the analog signal into the digital signal. Sampling differently, you know that the process in which the analog continuous signal are measured at equal intervals of time, and finally the discretized signal or the digital numbers we get. So this is known as your sampling. Sampling involves the quantization also. So let us see that how the quantization, it must be very, you know, just let me increase the font size. If it is possible, then it will be a bit visible. Okay, so I suppose it is visible. Here. Okay. So this is your first thing, that is your simple what we are doing, that is your f0, that is your frequency of sine wave in hertz. Then ft is your sampling frequency, because you have to, if you want to quantize, you have to give the sampling frequency from which we have to calculate the time period, right? So what we have done here, that is your simple t is equal to, we have taken the range from 0 to 1 with a gap of 0.01, and we are taking the time period is equal to 1 by ft. That's why only the sampling frequency we are taking, and it will be 1 by ft, that is your time period. After that, we are creating simple sine signal, that is your x equal to sine twice pi ft. F, now it is your input frequency, that is your f0. After that, we have doing that plotting and some you know, that text and label text and all these things. You are changing x label and y label. Title you have given. Now this part we are doing that the quantization part. Quantization, we know that if we change t to nt, that is your quantization, right? So what we are doing here, that n is equal to 0 to ft, that is our sampling frequency range, because ft we have taken as a sampling frequency. So we are doing that y is equal to sine twice pi f, then without t, here we were using the t, now we are using that, in replace of t we are using nt, and n is your 0 to ft. That means we are doing the sampling here, and after that again we are plotting, but only difference is that there we are using the plot command, here we are using plot 2d3. Plot 2d3 command is basically used, you must have used it, this is used for plotting the sampled signal, right? So for example, in MATLAB we use the stem signal for plotting the sample signal. In SCILAB we use the plot 2d3 command for plotting the sample signal. So that we have done, and finally we will get the sample signal. This we will check that when during the practice period we will check all these things. So you can just note down this thing, that a simple frequency we will input, and one sampling frequency we will input. We will give the time period will be 1 by ft. We will take any signal, that may be cosine, maybe sine, maybe tan, anything, any signal you can just take it. After that you can plot the continuous signal as you have learned till today, that how to plot the continuous signal, and after that you can do the sampling, that is replacing t with nt, and after that you can get this, and n is equal to 0 to ft, and t you have calculated, this is constant, that is your 1 by ft. So this way you can get the sampling signal. And this is your work, that where you have learned that random signal, how to generate sine and cosine signal, that you can just do it yourself, that how to create the step signal, ramp signal, and exponential signal. Now let us directly go to the convolution. As we know that what is the convolution is needed, there must be some need, so that we should learn that to use of that function or use of that equipment. If at home you can just see that if anything is required, then only we buy from the market, otherwise we don't buy, right? Here also in signal processing, if there is an importance of anything, then only we will learn and we will use, otherwise we will not learn. So convolution is a term which is used to find out the response, that is your output response. For example, if you want to calculate any output response of a system, what do you want? You want the input signal, you want the transfer function of that signal, then only you can find out the output of that system, right? Now question is that if you don't have the transfer function of that system, then what you will do? You cannot find out the output of a system if you don't know the transfer function. But convolution has told us that if you know the input signal and the impulse response of that signal, that is known termed in signal processing, that is your HN, that is your the response of an impulse signal. Impulse signal we say as your delta n, that is equal to 1 at time t is equal to 0, and it is 0 at all other times. So if the response of that impulse signal is known to you, that is Hn is known to you of that system, and if you know the input signal, then you can find out the output of a system without knowing the transfer function with the help of the convolution. So that is the actually significance of finding out the convolution, that where we use it. So convolution is basically we calculate with the in SCILAB programming. We are concentrating on the SCILAB programming only. We will not go to mathematical or the analytical expression of convolution. So this is your convolution A comma B. A is your any matrix, B is your any matrix. It is a vector, not matrix. For the matrix there is a different command. If it is a vector, that is A is a vector, B is a vector, then after that shape, there is an option shape. Shape is basically what? Whenever you find the analytical or the mathematical computation of convolution, you get the size of the convolution matrix is your size of A plus size of B minus 1. Generally in mathematical computation, if your x is your one vector of 7 values and y is your another vector of 8 values, then whenever you will find out the convolution of x and y, you will get the value 7 plus 8, that is 15 minus 1, that is 14 values you will get. So here also in SCILAB programming, shape means it will give the two options. One is your full. If you give the full that I have written here, if you give the full command is here, then you will get as it is all the values, that is your size of A plus size of B minus 1. Those values you will get. But if you give the value same, another option they are giving the same, then you will get the equal values as size A. That means first matrix size, the values will be as the same values in the matrix A. But which values it will take? Because you have got the, for example, 14 values. Now we have to take the 7 values. Now which 7 values it will take? It will not take from the beginning to for 7 values. It will take the center 7 values. It will automatically calculate the center 7 values and it will give you that these are the values of the center of the convolution, but the size of the values is the same as your size A. If your size A was 7, then it will give the 7 values. If your size A was 8, then it will give the 8 values. So this is the basic programming of the convolution to find out the convolution of A and B. So this is the case when A and B are the vectors. But if your A and B, they have given another option that if A and B are not the vector, these are matrices, then what you will do? That time we have to do the convolve CONV 2. That is 2 represents the 2-dimensional convolution. So here we will write that C is equal to, that I have written here, C is equal to CONV2, that is for 2D convolution. And after that A comma B, that are your 2 matrices. And again the shape, that is actually same option, that is your whatever shape you will give. Full means all these things that I have told, size A, size B and minus 1. And after that, if it is your A, then it will be same size of A. But without writing A and B, there is a different way that you can write again. What I have done, that without replacing A, we are giving H row and H column. There are 2 vectors. A is, I have told you, that is a matrix. That means that may be of 2, 3, 3, 4. That means 2 by 2 matrix. But you can enter like this, that first of all the row values, after that the column. That means you can write that the 2 vectors you can write. H row is a vector and H column is also a vector. That means without writing 2, 2, 2, 3, you can write here one matrix, you can write 2 and 2, another matrix you can write 2 and 3. After that you can write B. So this is the example that we have done here, that the both the results will be same. Now here I will doing, that is your S. This is a constant matrix, it is a Sobel operator. When we do the Sobel operator, we use the Sobel operator for in image processing. This is a constant matrix we use for the Sobel for the edge detection. For example, that are scanny detection are there, Sobel detection are there. So this is your Sobel detection matrix. So whenever you use the Sobel operator in case of image processing, you have to give this type of matrix. So this is your 1 to 1, 0, 0, 0, and minus 1, minus 2, minus 1. This is a constant matrix of Sobel operator. This is one matrix, that is your with row and column. It may be the 2 by 3, it may be 3 by 3, it may be the 4 by 4, any matrix it can be given. Now another matrix is your A, that is your zeros matrix. What we have done, that is your zeros matrix 10 by 10, right? And for 3 to 7 and 3 to 7, it will be 1. So you will get some value 0, 0, 1, 0, 0, 0, 1 or 0, 0, 1, 1, 1, 1. Then after that again 0, 0, 0. Like this you will get the 10 by 10 matrix. First of all, we have initialized to zeros, and after that some values we have converted into 1. Now we are doing the first option, that is this option we are doing A comma B and shape. So what we have done, that is convolve 2, that is your CONV2. S is your one matrix, A is your another matrix, and this is your full. That means the option we have given full. After that, what we have done, that this option, if we want to try, then what will be the case? That H row and H column. So we are taking two matrices, that is your 1, 0, -1 and 1, 2, 1. This is the two matrices we have taken. Now we are doing convolve to u, v, a. It represents that you are telling the three-dimensional, with three matrices you are doing the convolution, but it is not the case. You are doing the two-dimensional only, but here u and v are the vectors which they are considering. After combining, they are considering as a matrix, and A is a simple matrix. Right? So here we are doing that. We have learned that how to consider the single vector convolution, that is your CONV. After that, we have learned that how to do the two-dimensional matrix convolution, that is with the help of CONV2. And after that, we have learned that if you don't give matrix, if you are entering one is your matrix form, another matrix is your vector form, then also we can use the CONV2. Next is your CONVOL2D. That is your 2D convolution, that is a two-dimensional convolution only, but the internal calculation will be in the FFT form. That means this convolution will take much lesser time and much less complication or the complex multiplications and additions. So this is your discrete 2D convolution using FFT. You will not understand that from the outside that what it is doing, but internally when internal the programming it is done, that with FFT only we have found out the convolution. So it is same as your CONVOL2D and A, B. Otherwise, other options are the same, that is shape and all these things, it is same. So here I have written that S is equal to one matrix and A is equal to another matrix, then CONVOL2D S, A. But you will not understand that what is the difference from the outside, that CONV2, what is the difference between CONV2 and CONVOL2D. But whenever you will do a large application, real-time application where the time matters, where the computation matters, that time you will understand that if you use this type of command, then how the less complicated or less complex solutions you get. After that, another command is your detrend. That is your detrend. Right? DED, then trend. That means you are cutting, DE matlab you are removing the trend of that signal. What is the trend? It may be, it removes, it is telling constant, linear or piecewise linear trend from a vector. For example, let us give an example. So this is a graph, that is a blue color one graph is there and red color straight graph is there. So blue color graph is representing that it is your, this blue color graph that is representing, say this is your piecewise linear graph. That is a linear graph and piecewise linear graph. But whenever we are using the D trend, we are cutting that trend of linearity and we are converting into a constant signal. So whenever this type of application you require, for example, you have the, linearity graph, but you want to cut it into the constant graph, something somewhere about. So that time we use the D trend. It may be of any trend, but nowadays, till today, in Scilab, this D trend command that cut out only the linearity or the piecewise linearity graph. So here we have written that linspace, as you know that what do you mean by linspace? Linspace is your initial and final value and over this step, that is 16 into %pi. And after that, we are giving the equation, that is a linear equation. It may be anything, -20 and plus sine 2t and sine t. And you can just say that piecewise linear. That's why the name is your piecewise linear. Simple linear means just a linear graph, right? One straight line will be there. Piecewise linear means you will get piece by piece, and when you join those pieces, it will be a linearity form. But within that piece, you will get the sinusoidal signal. Here you will, maybe sinusoidal, maybe any type graph. So here we are giving that, for example, 0.3 sine 0.5t. You may say, okay, is it a linear? Yes. It is linear piecewise. That's why the name is your piecewise. But if we take the one piece by one piece, within that piece, it may be the sinusoidal signal, maybe the cosine signal, maybe another signal, right? So this is the difference between the linear signal and the piecewise linear signal. So what we are doing here, we are getting that x is equal to piecewise linear graph, and after that we are giving dtrend command. Sorry. So we are getting the dtrend command. We are giving that this is your x, that is your input, and after that L is your, you just removing the linear signal, and 7, that means 7 points. After the 7 points, it will cut. For example, I will just tell you that what is the basic programming. It says either you can give the detrend x, that is your completely open, that wherever it will cut the two signal, it may cut. Here we are giving that x flag. Flag means it is a string that is your for linear and piecewise linear statement, or constant for C. That means you are treating the constant treatment you are giving. That means you are cutting the trend of a constant signal. So here we are taking that L, that is, we know that this is R is your linear or piecewise linear. BP is a breakpoint. Breakpoint is giving that it will give the breakpoints to provide if you want a piecewise linear treatment. For example, here we are giving 7. 7 means that after the 7 pieces, 1, 2, 3, 4, 5, 6, 7. Like this, you continue the number 7, and after 7, you will get the breakpoint. That means it will cut at number 7, it will cut the constant and also the linear signal. So that is your breakpoint. For example, if you are giving the breakpoint as your 9, nothing will happen. Otherwise, nowhere we are giving that it will start from 0 or something, right? Whenever you will give that breakpoint is 9, this signal will go up and it will give somewhere here, so that here it will the break of this linearity, and is your constant signal, it will be done, and the number of breakpoints will be 9. For example, if you are giving the breakpoint as 15, this graph, that is your constant graph, will go up. Where it will cut, then that point, number of points it will be, you will get as your 15. So this is your breakpoint, that where you want to give the breakpoint of your trend, right? So that is your detrend. So after that, we have given this grid, and on if you want to on the grid, then we can give the grid function and all that you must have learned. With the help of GCA command also we can give the grids. CLF is your clear the figure, that if you have the any figure before that, you have to clear it up. After that, next let us come to the discrete Fourier transform. Okay, till now, this point, we have learned that how to make a random signal, we have learned, and we have given the work that how to produce the ramp signal, step signal, or the exponential signal. And also we have learned that how to sample one signal with this T and NT. And we have learned that how to do the convolution, what is the significance of convolution, or what is the importance of convolution. Then we have learned that in convolution, we can do the convolution between the two vectors, and we have learned the convolution between the two matrices. And after that, we have learned that convolution with matrices with FFT transform. Next, we have done that how to do the delete the trend of a signal. Now we are coming to the discrete Fourier transform. Now the Fourier transform, as you know, that what is the need of Fourier transform? That is basically to convert any analog signal to the frequency transform. That is the need of Fourier transform. Now, there are many transforms are there. For example, when you say in analog signal, that Laplace transform is there. When we'll come to the digital signals, then jet transform are there. Then when we'll convert into the frequency signal, then Fourier transform is there. After that, we have learned that how to discretize the Fourier transform. That name is your DFT. That is your discrete Fourier transform. Don't think that it is the Fourier transform of a digital signal. No, this is not the case. Fourier transform of a digital signal, it is not the discrete Fourier transform. Discrete Fourier transform is your, after finding the Fourier transform of a signal, you are discretizing that Fourier transform, right? There is a difference between these two terms. Sometimes we say that if we convert the analog signal, then we will get the Fourier transform, and if we convert the digital signal, we'll get the discrete Fourier transform. No, this is not the case, right? So you should be very clear. If you have xn, then you can find out the x omega, or you can find out the x t, that is your, we can say the discrete Fourier transform. First of all, you may t, and discrete Fourier transform we can say omega. So after the discretization, we can get the xk, that is your discrete Fourier transform. So here we are telling that xf, that is your, after Fourier discrete Fourier transform, what will be the command, that is your DFT. So in DFT, in SCILAB, basically what happened in MATLAB, for DFT we get the DFT command, and for the inverse DFT we get the IDFT command, that is your inverse DFT. But in case of SCILAB, they have given for DFT also we will use the DFT, and for inverse DFT also we will use only DFT only. But difference is in the flag. If you give the flag as your -1, that means you are finding the DFT. If you are giving flag is equal to 1, that means you are finding the IDFT. So you should be very clear that for finding the DFT also we will use DFT command, and to find the inverse DFT also we will use the DFT command. Only the flag differences is there. If the flag is -1, that means DFT. Flag is equal to +1, that means this is your IDFT. And finally you will get the output vector. So this is one example. This is very simple, that A is a matrix, and if you are -1, then you are getting this, and if it is +1, then you are getting the inverse DFT. Okay, this is x, whatever input, that is can be with the single variable, and this is also multivariate also, and it is the multi-dimensional signal also can be done. There is no problem at all. Matlab here A is maybe the only vector or matrix. There will be not any problem in there in SCILAB programming. Right. So for the FFT, we get the FFT command. As you know, there is a difference between the DFT and FFT is that it is fast. First Fourier transform, near about when you know, whoever knows the signal processing, when you do the mathematical calculations, then you will find there is a, the common thinking is there for the students, that they think that DFT, that only 2 steps we can calculate DFT with the e⁻j omega t into dt. But in case of the FFT, we get so many, butterfly techniques are there, so many calculations are there. After that, we find the FFT. Without commands if you want to do. So there is a concept that FFT requires so much time and DFT requires only the 2 lines, e⁻j omega t, then only you can find out the DFT. But main point is that actually the calculations or the mathematical calculations or additions involved in FFT are much less compared to your DFT. So that's why this requires a less amount of time. And finally, when you get so many commands in your application, that time you can find out that how FFT gives you the better solution. So FFT gives by name only you can understand that is your first Fourier transform. So I'll not go in very details of FFT. So here also same is your FFT. If it is your -1, then it is your FFT. And if you give the +1, that means you are calculating the IFFT. So this is just an example. We are taking that this example definitely we will run, and this is your n is equal to 8. That is order, that is your n is equal to 8. Then omega you can take anything, twice by fn, -2 by fn, whatever you want to take. Then you are calculating that x into -1, and then we are taking that DFT x -1. That means first of all we are finding the FFT and DFT, and finally we are finding the IDFT, and we are checking it that how it will come. That is, this is your j is equal to 0 to n minus 1 that we have taken. F is equal to omega into that is e to the power minus omega twice by omega n into t. So that we are doing here. So we are definitely in this program, we are calculating with the FFT and DFT, and we are finding out that whether actual result we are comparing, that whether we are getting the actual result or not. Here we are getting f into x, that we are finding out, that is FFT and DFT, and after that we are finding out the inverse, and again we are checking with that whether we are getting the same value of inverse or not, right? This is your FFT shift. FFT shift is nothing but a sometimes when we'll do the spectrum, when we'll find out the frequency spectrum, sometimes we have to shift the origin of the spectrum, right? So FFT shift is nothing but to shift the origin of the spectrum. So here we are giving that y is equal to, the command is your y is equal to FFT shift x, and then after that this is your option, that what option you want to give, right? If you are x, you are giving that is FFT shift x. After that you are giving all. All means that it will shift the spectrum from 0 to center, right? Directly it will go from 0 to center. That means, or afterwards, if you want to give any point, any value or the pixel point, if you are giving, for example, you are giving 7 or 8, then it will move into the x-axis some 7 points, and after that it will move the spectrum. So you can just check it, that how it will be in the center of the spectrum or somewhere into the other points of the frequency point, right? So this is your FFT shift, that how you can get the shifting of the FFT output, moving the 0 frequency to the center of the spectrum with the help of this x comma all. If you write all, then it will move the frequency. So this is one command. I suppose that it is not so much visible. So let me just, just insert another. Just 2 minutes. I will just enter. Oh. Okay, so let us take it as a bit big font so that the other centers may check it. Okay, now this is your FFT shift. We have got it. Right, next, let us see. So here we have done, that is t is equal to 0 to 1000, that is your with the difference of 0.1, and after that we are giving the same signal, that is your piecewise linearity signal, 3 into sine t plus 8 into sine 3t plus 0.5 into sine 5t plus 3 into randomize of t, and we have calculating the FFT. And similarly you can plot also with the help of this and plot 2D FFT shift. Right, I have given this FFT, and finally I have given that this is your y. So we are calculating the absolute y, that means you will get only the magnitude values, and after we have this, that you shift this FFT shift. With the help of FFT shift we are shifting. So next one, again we are telling that this is your IDFT or FFT we are finding, that is xm to -1, and finally what we are doing, that is your mat plot. You can just check it, that what is the command of this, right? This is your hot color map, that means all your graph will be, that is with the help of this RGB color that we have given the 256. So you can just see that what will be the background color and all these things. So I suppose that this command you can take, whenever I will complete this session, then it will be uploaded automatically in the YouTube. Then you can just immediately, you can just check it. I suppose immediately it will be uploaded. Immediately you can just check it, and you can take the, this command, and then you can try on your laptop. Otherwise, I will show one by one. Some time we will give. Then is your multi-dimensional FFT, that is your MFFT, right? Multi-dimensional means that is your X may be of multi-dimensional. Then after that, you can find out the FFT, right? This is your correlation, that is your how to find out the correlation between the two signals. That is your, if X is a signal and Y is another signal, so how to find out the correlation among these two, between these two signals. What is the correlation? What is the similarity between these two? One is your X chord, that is as MATLAB, in MATLAB we have used, that is your X chord, and that is your XCOV, that is your covariance, that is your how much variance of a signal from the other signal, that is your covariance. So there are two commands. One is your X chord, another is your XCOV. So these are the two commands we have used for the correlation of the signals. So we have basic signals we have learned, that is your how to plot the signals, how to do the convolution of the signal, how to do the DFTs or the FFTs of the signal, how to detrend the signal, and how to find out the correlation and the covariance of the signal, and how to do the multidimensional FFT. So these are the basic things. After that, we will just jump to the filters. But before that, let us try one by one. For 15 minutes, we will take the practice session. But before that, any questions from your side? Then of this, this PPTs or all these things, and we will take then after that 15 minutes or 20 minutes for practice. I will do the here also, and you can do at your side. We'll just check that what is the output. Any questions from your side? Any center, any question from your side? After that, we will try to do the practically.
Engineering College, any question from your side?
From Northern India Engineering College, any question from your side?
No, madam, thank you.
Okay, from other college.
MVSIT, Sonipat, any question from your side? MSIT?
No questions, ma'am. Thank you.
Okay, fine. Let us see that what is the output of the, what are the commands we have written here. Then let me just start the SCILAB programming. So these are some commands we have written here. Let me write into the SCI Notes. some commands we have written, just we have done the copy and paste to find out the what will be the sinusoidal signal, and after that we have found out the what is the sample signal. Now let us run it, right? Whatever we have written, that is your, for example, we have written that is F0 and FT after the time period, then we have done the sample signal, then we have plotted the sample signal. Now if we run it, so let us save the file. So it is asking me, when I have executed the file, it is asking me frequency of sine wave in hertz. What it is asking me, that is I have given the input command, it is giving that frequency of sine wave in hertz, that what frequency you want to give, right? So let me just input that frequency I want to give, for example, 300 hertz. Next, it is asking that sampling frequency. It may be more than twice, because at the Nyquist rate we have found out that the sampling frequency should be twice the frequency. So let me give the 700, right? Then it is giving, this is your just sampled, this is what your continuous signal, this is your Windows is a bit, it is the signal I have given as your, I suppose that sine twice by f0 into t. If you give the frequency rate is small, then you will get the sinusoidal signal, and after that it is giving the sample signal. So let me say, for example, again, let me run the program again. Then we will give the sample signal a bit less frequency. So your frequency, let me give the 550 hertz, and is your sample frequency, maybe you can give your 100 hertz or more than that. Now if you see the graph, okay, then just 1 minute. You have to do the CLF. Right, so here you will get the better picture that this is your sinusoidal signal, and depending on your time, basically it is coming that triangular, but if you give the smaller time, then gap is your small, then you will get the sinusoidal signal, and this is your sample signal. At each and every point we are getting the sample signal, right? So this is your, with the help of the plot 2D3 command, and this is your simple plot command. So this is your one program that we have run, and another you can say that is your convolution. So let me try the convolution again. So this is your convolution signal, that is S is equal to this, A is equal to this, and convol 2, and after that we have done the again convol 2 with the two vectors. So let us try again. So here only in the same command we are plotting it. You can just see the plot command or the plot 2D3 command, then you will get the values. the matrix values you can see here, that what are the P and Q values are there, what is the variable. And if you want to show, then you can see the display matrix, then you can, it will display command, then you can see the all the values, right? So similarly, this is your you know, convolution signal what we are putting out. And after that you can plot also. If you give the plot command, then also you will get the signal values, that how it is plotting it, right? Similarly, you can get, you know, that is your convol 2D command. And for example, let us try this Bittern command, right? This is your Bittern command. Now let us see. Here only I will just replace that command. You can say this, how it will look like, right? So this is the signal what we are getting. That is your blue color is your before detrend, and after detrend is your red color. So blue color, it is giving just a signal, that is your x equal to this, and we are plotting that x, right? Plot 2D command, what we are getting, in the same command we are plotting x also and y also, and with the help of t. T is your common, that is 0 to 1000, and 16 into pi will be the difference. And after that you are plotting that x and y both, and style is your 2 and 5. Style 2 and 5 means that you are plotting that you know, graph with the blue color, or with the help of the this maroon color or something, right? So this is your, with the help of this SCILAB programming, we can just plot that this is your linearity signal and this is your detrend, that is your constant signal. When you cut the linearity, then you will get the constant signal. So one thing we have done here. Next is your DFT. DFT is simple DFT you can plot. Oh, here you have to do one thing, that is your if the DFT is not working, most probably that may be the, because FFT we are getting, but DFT there is some undefined variable. Maybe this in SCILAB, this DFT command, this version, the DFT command does not, you know, this is your 5.5.2. Yes, in this you just take care of that. In case of the SCILAB 5.5.2, what it is, it has been loaded here. This is not the, I suppose this is not the recent version of the SCILAB. It is maybe you have loaded or they have loaded. So the version is your 5.6. In that version, the DFT command will be used. But in case of 5.5.2, this DFT command will not run. But no problem. The DFT command also will give the same. If you are loading the 5.5.2 and if it does not work, don't worry. If you give the FFT command also, then also you will get the same value as DFT only. So don't worry about that. The result will be the same. So you can use the FFT or you can use the DFT command. There will be no problem at all. Sometimes, so depending on the versions, this command does not work. That is, don't worry about that. So here this FFT is working, so you can get the result that what will be the FFT and what will be the FFT IDFT, right? Yes. Next is your shifting, that how the FFT can be shifted. So let us try this program. So this is your FFT shifting that I have told you, that how to do the FFT shifting. If you do calculate the FFT and then you plot, then you will get this type of program, this type of graph. And after that you are shifting to the center. So when we have given the L command, all command, then we are getting the FFT shifting to the center point. So this only we have done here, that how to shifting the FFT, and after that how to shift the IDFT, right? Or IFFT, whatever you want to give. So this is your how to change the color map and all. Let us see that how it will affect. Let me close the graphic window. Right? So this is the effect of your color map. So whenever you give the some color map, you can just check it with the help command. You can just check it that what is the command of hot color map, what is the command of matplot, right? It will be the plotting within a matrix form, right? Within the column and rows form, just like as a grid. So that is your matplot. So how it is giving the result? So here I have just shown you the effect of this hot color map. We have given the 256. You can give the different color also. Then whatever color you will get, depending on this, you will get the matrix form, right? So this is your, you are getting, this is your, this white color, that line, it is representing the FFT. Here also this white color line, it is representing the FFT. Now, whenever we have given the shifting, then this FFT has been shifted here. But the background you are getting as your hot color map. So these are the some commands that you can try to, you know, in your programming environment, that how it will affect or how it will do the calculations. Similarly, you can do the X correlation with the help of, if you want to give the correlation, that there are two correlation. One is your autocorrelation, another is your cross correlation. Autocorrelation is that whenever you will do the correlation among within the same signals, then it is known as your autocorrelation. And if you want to calculate the, you know, the correlation among the between the two signals, then it is known as your cross correlation. So this is all about your initial, you know, the signal processing applications. Now let us go to next part, that is your filter. At what time the tea break is there? 11 o'clock. 11 o'clock. Okay, fine. Now we will do some parts of the filter here, and after that, after the tea break, we will continue the filter commands, right? So let us start the filters. So this is the filter design session on our filter design. Now filter is basically what for filter is used, that you know, just to cut the noises from the signal we use the filter. Just like as filter we use at home to filterize the drinking water. So that's what, that way we filter the noises from the signal, and then we can process those signals into the filters, right? So there are two types of filters. One is your analog filter, another is your digital filter. When the when we remove in both the cases only, we remove the unwanted signal. Analog filters uses the inductors, capacitors, and produce the required effects. And digital filter generally they uses the processors for doing the same. Now directly let us come to the filter command. What do the filter command is? Filter, that is your filter command, numerator comma denominator. Basically filter as a we say that this is a filter function. The filter function consists of, just like as your transfer function, that means something into the numerator and some terms into the denominator. Then only we can say this is a filter function or the transfer function of the filter. So this is your some, you know, vector or the matrix form in your numerator, and after that some, you know, that is in the denominator, and X is your input signal, which signal you want to filter. That means to filterize any signal, we want the input signal, and after that we want the filter transfer function, and then our output side we get the filtered signal. So input signal, it is represented as your X, and the transfer function of the filter, that means filter system function, it will be designated with the numerator and the denominator, something divided by something. And after that, the output will be designated as your y, that is your filtered signal. So the numerator can be the real vector, and denominator also can be the vector. Numerator is the coefficients of the filter numerator in decreasing power order, and the denominator also we will get the coefficients of the filter denominator in the decreasing order. Now this is the filter command, that is your numerator. Let us see that 1, 2, 3, 5, 6, and denominator we are giving any variable, that is your 3, 4, 5, 6, and after that this is our initial signal, that is 1, 2, 3, 4, 5, 6, 7, and after that if you give the filter command y is equal to filter numerator comma denominator and x, you will get the plot y. Now we will see next that how to plot these commands. Next, in the filter, there are two types of filter. One is in digital filter, you can say we have converted to the digital filter. After that, we will go to the analog filter. In digital filter, it can be differentiated as the finite impulse response filter and also the infinite impulse response filter. That means FIR and IIR. So FIR is your finite impulse response. What do you mean by finite impulse response? We know what is your impulse signal, that is your delta n. We know what is your response of the impulse signal, that is your Hn. That means whenever you will, what output you will get if you give the impulse signal as your input, that is your output, that is your impulse response, that is your Hn. And after that, that Hn values, if you have the finite values, then we can say this is your FIR filter. If that Hn contains the infinite values, then we can say this is your IIR filter. What do you mean by that? For example, Hn equal to, I am giving Hn equal to, the values are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Complete. So this is your one Hn. And another Hn we are giving, that Hn equal to Un, right? That is your step signal. That means it will be 1 for all the values n greater than 0. It is an infinite impulse response. So first one is your FIR filter. Next one is your infinite impulse response filter. So again, in FIR and IIR, in both the cases, these are the two digital filters, FIR and IIR. In both the cases, we will get the 4 options. What are the 4 options? We can get the low pass filter in FIR. We can get the band pass filter in FIR. We can get the high pass filter also in FIR. We can get the band stop filter in also FIR. That means 4 options are available both in FIR and as well as in IIR. Now in this case, we are getting that FIR of low pass filter. In the low pass filter means it will pass the low frequencies, but it will stop the high frequencies. That's why the name is your low pass filter. So FP is your enter the cutoff frequency that we are giving, that where the cutoff frequency will be there. N is equal to order of the filter, and F is equal to that and enter the sampling frequency. That is your 2 frequency we have to give. One is your cutoff frequency FC, where the filter will be cut into the and it will come to the stop band. And after that, you have to give the sampling frequency also. Now for the FIR filter, generally we use the windowing technique. If you know the signal processing, then if you know the filtering techniques, you can get to know that there are various methods of finding out the FIR filter design. One is your windowing filtering. Windowing means any type of window you can use. Maybe the rectangular window, maybe the Hamming window, maybe the Bartlett window, maybe the Kaiser window. There are so many windowing capabilities are there with which you can find out the filtering effect. But here, in case of signal processing, generally the researchers have found out and they have proved that in signal processing, generally we use the Hamming window, right? And for the filter design in SCILAB programming, we have used this WFIR. This is the window FIR filter. That means by the name only you can understand that this FIR filter has been designed by the window technique. So in this FIR, WFIR command, there are the options are there. What are the options? First of all, as I have written, this is your FIR filter, but low pass filter. So I have given LP. If you want to design high pass filter, you have to give HP. If you want to give the band pass filter, you have to give the BP. But if you want to design the band stop filter, then you don't have to give the BS, band stop. You have to give the ulta, that is your SB, right? So for low pass filter, it is your LP. For high pass filter, it is your HP. For band pass filter, it is your BP. But the stop band filter, it is your SB, right? After that, N is your order of the filter. That is must in every design. First of all, you have to design, or you have to just designate that what is the order of the filter. It may be 8, maybe 16, maybe 64, maybe 32, maybe 100, whatever order of the filter you want to give. After that, that is your cutoff frequency you have to give, right? Since I have given the low pass filter, so I have given the only one cutoff, right? For high pass filter also, we have to give only one cutoff. But for band pass filter and for the stop band filter, we have to give the 2 cutoff frequency. Now, let me just consider the pointer options. Let me take as a pen options. I will just tell you that what is the low pass filter and what is the band pass filter. So in case of the low pass filter, what we get, that this is your low pass and this is your, that means this point is your is equal to the cutoff frequency for the low pass filter. Whenever we say the high pass filter means that the higher frequency will be pass and the low frequency will be cut off. So this is your high frequency. So here also we want one frequency cutoff, and here also we want the one frequency cutoff. So for the low pass filter and for the high pass filter, only one cutoff frequency we have to give, that is your WC, whatever frequency you want to give, and the other parameter will be 0, right, for the LP and for HP. But in band pass filter or in the stop band filter, we use the 2 frequency. So this is your WC1 and WC2. That time you have to give 2 values, WC1 and WC2, whatever frequency you want to give. For band stop also, you have to give the 2 frequency, because for the band stop case also, there will be this will be the case that in this band it will be stopped and other bands it will be on, right? So this is your 4 types of filter. So depending on this frequency will vary, cutoff frequency. So what we have come to know, that for low pass filter and for high pass filter, this will be only one value, that is your WC, and 0, that is one cutoff frequency, and other value will be 0. But for band pass filter, BP or SB, that is a stop band filter, we have to give the 2 values. That means we have to enter the 2 cutoff frequency, that is FP1 and FP2. Similarly, you have to calculate WC1 and WC2. Here you have to give WC1 and here you have to give WC2. After that, you are giving that which type of window you are using. If it is a rectangular window, then you have to give R. If you give the Hamming window, then you have to give the HM. If you have to give the Henning window, Henning, H-A-N-N-I-N-G, then you have to give the HN. If you give the Bartlett window, you have to give the BAR. So write this different types of window you can use. Here we have used the Hamming window, so that is your HM. This 0, 0, these are 2 parameters. These parameters varies because these are known as your parameters of the frequency. For the Hamming window and for rectangular, these are all available in case of WFIR. When you will search the help WFIR, you will get all the values, because it is just impossible to remember all these parameters, that what will be the values. So whenever you do the calculations or the any programming, definitely you will start that what the help command says. This is a very strong command we have to take in consideration. Wherever applications it is needed, you can use this help command. So these 2 parameters, these are known as your frequency parameters. These are known as your FPAR, right? So these parameters depends that if it is a Kaiser window, then first value will be 0, next value can be less than 1, or it may be the 0.5. So for the Hamming window, both can be 0. For the rectangular window also, both can be 0. So like this, it is varied. But if you keep 0, 0, then everywhere it will be the same, because in each and every window cases, 0, 0 are the valid parameters for each and every window. So you can keep it constant also in every case 0, 0. Otherwise, you can change the parameters according to your requirement that you can see in the help command. What we are getting, that if you are giving this WFIR command, full command, I suppose that it is clear to you all the parameters, LP, N, WC0, Hamming, and these are the default parameters. So whenever you will calculate this WFIR, so 3 values you will get. One is your coefficient of the filter, another is your frequency, amplitude of the frequency, and this is your frequency of the frequency signal, right? When you will get the frequency transform, you get the amplitude as well as the frequency component, right? So this is your frequency component and this is your amplitude component. And these are your filter component, filter values. So these are the 3 values you will get. So whenever you will plot the frequency response, here I am giving that this is my frequency response. So in case of frequency response, what we are getting, this is your X side, that is your x-axis, that is your f frequency, and this is your y side, that is your f amplitude. We are calculating only the frequency response of the filter. If you want to plot the filter coefficients, then we will give the COEFFVAL with respect to f frequency, right? So that is what type of plot you will get. And after that, frequency, magnitude, and this is your title, that is your FIR low pass filter. Thus we can see that in case of the SCILAB, how it will affect. Similarly, similar case, IIR LPF. Only difference is that in case of IIR, we are giving the command as IIR. There we is to give the command is your WFIR, right? Here I am giving the IIR command. Otherwise, N is your before. In IIR, the order of the filter is before, that is your N. LP, that is your low pass. And all the IIR filters can be designed with the help of the analog filters. Now there are 4 analog filters are available in case of signal processing generally. One is your Butterworth filter, second one is your Chebyshev 1 filter, number 3 is your Chebyshev 2 filter, and 4th one is your elliptical filter. So here I am doing that N is your order of the filter, LP is your low pass filter, this is your from Butterworth filter, that is your BUTT. And as you know, in LP, we get WC0 only because we get only 1 cutoff frequency. And finally, the parameters are we are taking 0, 0. Here, another way we have come out with the output, that is we are taking the output only one function, that is your one variable, that is your HZ. From the SZ, we can find out the magnitude of the frequency or the component of the frequency. For that, the command is your FRMAG. There are different ways of writing. Either we can write here like this, coefficient, comma FM, comma FREQ frequency, or you can give the command output in a one function, one variable, that is HZ. And from the HZ, with the 256 values, frequency values, we'll get 256 frequency values, and we will get the frequency values, and here we'll get the magnitude. So we are getting plot 2D, then frequency and magnitude, and after that you are getting the output, and it will be known as your IIR filter low pass. Here I have given 2D, that's why we are getting the discrete IIR filter, right? So in this session we will just stop here only. So we have learnt in filter that what is the common design of the filter, that is a simple filter command with the numerator, denominator, and the input signal. After that we have found out that how to design an FIR filter with the help of the WFIR command, and how to design an IIR filter of low pass with the help of the IIR command. You can use with, that is without LP, you can use HP, you can use BP, we can use SB, and all these things you can practice yourself. And after the tea break, again we will come and we will definitely will do the practical of this programming. We will run into the SCILAB environment, and after that we will continue with the other commands. Thank you so much. Okay, welcome back again. So let us continue in filter design. Just like that, in the previous session, I have told up to IIR low pass filter. Just as an example, I have given that how to do the high pass filter. That similar way I have written that it should be HP, and then Butterworth filter we have used, and WC0, that means your only one cutoff frequency we have given, and similarly we have calculated the high pass filter, right? So this type of filter, if we just run in your SCILAB environment, you will get definitely the high pass filter response and all these things. We'll check. And next is your how to design the analog low pass filter. This IIR and FIR filter are the digital filters. Now we are doing the how to create the analog low pass filter. So for the analog low pass filter, we have the command that is your analpf, that is your ANALPF, analpf. Then after that, we are giving that N, that is your order of the filter. Then another is your string, one string F design. This string may contain these 4 options. If you are designing the Butterworth, then it is your BUTT. If you are designing the Chebyshev 1, that is your CHEB1, then Chebyshev 2, for that we give the CHEB2, and for elliptical filter we give the ELLIP. Now let us see that what are the different types, that if we give the Butterworth, then what type of filter response we will get. In case of why these names have been given, in case of Butterworth, we consider that there will be no ripple, right? There will be no ripple. That means it will be simple and very smoother way. So this is your Butterworth filter. But if we design the Chebyshev filter, then we will get the ripple in your pass band, but there will be no ripple in case of your stop band. So this is your Chebyshev 1. And similarly, if you say ki Chebyshev 2, then in case of Chebyshev 2, we will get the smoother option in your pass band. But whenever you will do in your stop band, then we can get the some ripples. That is your Chebyshev 2. In case of elliptical case, there will be the ripple in both the cases. So similar way we have to give the values also. So these are the 4 filter response. One is your Butterworth, another is your Chebyshev 1, and this is Chebyshev 1, this is Chebyshev 2, and this is your elliptic, right? So accordingly, you have to give the name. RP is the ripple and omega is the frequency. So this is your just a structure of the command, that is your analpf. Now that I have told that RP is the ripples, and what for Chebyshev 1 on that means in ripple there are 2 values should be there. There should be 2 values for the pass band and for the stop band. So in case of Butterworth filter, it will be 0 and 0. That means there will be no ripples. In case of Chebyshev 1, first value you have to give and the second value you have to 0. For the Chebyshev 2, first value will be 0 and the second value will be RP2, that is your stop band. In case of elliptical, both the values you have to give for the RP matrix. So let us see. So this is your this is your program. So should I continue? Okay. स्क्रीन में कुछ आ रहा है मुझे लग रहा है ना. नहीं कुछ और आ रहा है. चलो एनीवे लेट मी कंटिन्यू. उधर जा रहा है. So anyway, there are some disturbances here. Now it is fine. So the program is for the analog filter design. We have done that F cut we have taken as your F5. That is your cutoff frequency we have taken as your 5. And order of the filter is equal to we have taken as your 7. Now in this case, what we are doing, we are designing the 4 filters. One is your first one, we have given the 10, that is your analog filter order of 7. Then we are filtering, designing, we are Chebyshev 1, so CHEB1 we have given. After that, as I have told you, in case of Chebyshev 1, we have to give the first ripple value and the second ripple value we have given 0, right? For the Chebyshev 2, only the difference here only it is there. Only for the Chebyshev 2, 0 and 0.1. For the elliptical filter, both the ripples we have to give 0.1 and 0.1. And for Butterworth, it will be 0 and 0. And after that, omega is nothing but the twice pi f. So that was only we have done. This is your 5 we have taken and 2 into pi. Right, twice pi f we have given in every case. So here we are getting all the filter coefficients of the analog filter. And after that, nothing we have done. We have given to the frequency response. So one frequency response we have done earlier, that is your FR magnitude. That is your, this we have done FR MAG. Now there is a different command. You can use FR MAG also, but I have given the different command, that is your represent the frequency response. That is your REP FREQ. That is your, that how the frequency response can be represented in the form of the frequency magnitude and frequency component. So REP FREQ HC1, that is your, we have given the analog filter, 0, 15, that is the range we have given. After that, we are plotting that absolute value of HF and the frequency. That is, a frequency will be in the FR will be in the the x-axis side, and the y-axis side it will be only the magnitude of HF. That is absolute value of HF. And these are the 4 colors. That is your blue, yellow, red, and cyan color we have given. So if you draw this, then you can see that how the representation has been done and how the design of the filter has been done, and with the different color that we will see that how it will represent. This is your to find out the magnitude of the Butterworth filter directly, right? So we are giving the BUTT MAG, that is your magnitude of the Butterworth filter. From here also you will find the magnitude, that is we are giving here, that is a frequency magnitude, right? Frequency response, frequency magnitude, and frequency values. But here we are giving the Butterworth, that is your filter values directly. Right, we are giving order, then we are giving omega value and cutoff frequency for the cutoff frequency, and we are giving the sample values where the transmission must be evaluated, and directly you will get the filter values, that is the filter coefficients at the sample points. That is a BUTT MAG. For example, we have given here the squared magnitude response of the Butterworth filter, not frequency, magnitude. So here we are giving the MAG, that is your Butterworth magnitude, 13 is your filter order, then this is your cutoff frequency we have given in the omega, then we have given the filter value, sample values 1 to 1000, then you can plot it and you can find out the dB values, that is your magnitude, 20 log H whenever we'll do, it will be converted into the decibel values, and after that you can plot this. Similarly, we have CHEV1 magnitude, CHEB1 MAG, then CHEB2 MAG, and ELLIP MAG. So these are some programs that were depending on the type of the filter or the type of the command, you have to change the different parameters. And omega, here we write the epsilon also. Epsilon represents the ripples, and after that you can give the sample values. Now let us see, these are all the magnitude, and now let us see that how it will show if we have the in Scilab programming, if you see, then how it will affect. So let us copy this, and then we will again run into the Scilab environment. So these are, when we have run it, so these are the 4 values you have got. So Butterworth filter, that is your simple, you see, this is your Butterworth filter in cyan color, right? This is your in cyan color. After that, that blue color, this is the blue color that you are getting as your Chebyshev 1. That is your only the ripple in your passband, and in the stop band it will be as smoother as the Butterworth filter. And other one is your that is your smooth in case of yellow color, that is your smooth in is your passband, and in your stop band it will have some ripples, that is your Chebyshev 2. And in case of red color, you are getting the ripple in your passband as well as ripple in your stop band. So this is your elliptic filter, right? So this, you are getting that this type of values you will get. And similar, the options we don't have to tell it again. So these are the commands, and after that we give the frequency response and then we plot it. And similarly, the other points, if you want to see, that is your high pass filter and low pass filter. So let us see here, if we run it. So let me write in your SCI Notes, because we have to take the input from the user. So let us take the run it. So it is asking enter the cutoff frequency. For example, I am giving 50 cutoff frequency, order of the filter maybe 10, and enter the sampling frequency. For example, I am taking as your 100 sampling frequency. So you are getting, so this is your low pass filter. So this is their, as I have shown you, this is the exact, picture of the low pass filter. Similarly, you can draw the high pass filter also. And here I have given the IIR high pass filter. So let us draw the high pass filter of IIR, which will draw with the help of the Butterworth filter. Now let us see, we will just change into the IIR filter, then we will run it. So here also they are asking that first of all create the cutoff frequency. Let us give the same value, that is your 10, and the sample frequency let us take 100. So you'll getting, this is your high pass frequency, high pass filter. So it will go, after that it will go the straight. So this is your stop band, and after that it will pass. So this is your the graph of your high pass filter. Similarly, you can get the low pass filter also for the IIR case. You can get the low pass filter. So in this session, you can just now try, that is your own time. Now half an hour time is there you have. So you can just write all the filter commands. For example, if you want to try this filter commands, then let us try. That's only the numerator, denominator, and simple filter command we are giving. So let us try in case of this. So this is your simple filter. There is no low pass and high pass or anything we have not mentioned. This is just one signal is there, and after that you are creating one, you are passing through that signal into some filter system. After that you are getting the output. So one command we have learned this, only the filter command, and after that we have learned that FIR, LPF, I have shown IIR, LPF, IIR, HPF. Then how to find out the analog filter, that also I have shown you. That is your all the filter, Butterworth and the Chebyshev filter, and how it is different, how the ripples can be used as different, where the first ripple is there, where the second ripple is there, where the two ripples are there. So just like that, you have to design the filter. And besides it, we have learned about that how to find the magnitude of a particular filter directly with the help of BUT MAG, with the help of Chebyshev CHEB1 MAG, with the help of CHEB2 MAG, and ELLIP MAG. So these are all about the basic concepts of the filter, and in the previous session we have learned the basic concepts of signal processing. And that's all for today's session. And now let us take questions from all the centers. So now Deepika will ask one by one center. She will go one by one, and just let us see that what are the questions from the center. Then you can just do the practice session on your own. HMR Institute. HMR Institute, any questions from your side? No questions?
No question, ma'am.
Okay, then let us go to the next institute. MSIT. Any questions from your side? Yes, any question, ma'am?
Thank you, ma'am. Any question? Ma'am.
Hello.
Hello, yes, any questions?
No, ma'am. Thank you.
Okay, thank you so much. And any other? Okay, okay, fine. So your coordinator will come at, I suppose, at 12:30. There will be validation, and Dr. Lini Matthew will coordinate this thing. During this period, that is 20 minutes time we have, you can just try on your own in your laptops or all these things. I'll just, it will be available where? In the YouTube. So it is available in YouTube channel. So you can just check it and you can just try on your own all the commands that I have told in this session. Right? Okay, thank you so much. Dr. Lini Matthew will come in the validation.
Yes.
Hello to all the participants at the different remote centers and also to the coordinators. Northern India Engineering College Coordinator Professor Rajiv Sharma, HMR Institute Coordinator Mr. Ravinder Beniwal, because I got a message from Rajesh Yadav that he is not there today, and MSIT Madam Shifali, and MESIT Mr. Ravi. Hope you people are there and all your participants are also there. We will be starting the valediction session now. It is a convention in our department that all the department faculty members used to be here during the valediction of all our courses, but unfortunately they are all busy in some other activities. I have 3 more faculty members, but you have seen Madam Shifi and Madam Shimi that day, Dr. Shimi. She was also one of the faculty member in the department. And the other 2 are also having other short-term courses and other activities, so they could not come. There is one more training program, contact mode, is going on, and the classes in that is also going on, and we have master's degree programs. The classes of the master's degree program is also going on. So none of them could be with me, even though I told them no problem. So I just wanted to hear from you people now. 1 week, different sessions, 5 days, different sessions. We were talking and you were listening. And now I wanted some feedback about the course, MATLAB and SCILAB, what all we can improve in it. So one by one, I will call the centers. One or 2 or 3 of your participants who had attended the program can give the feedback. Then if you have your director or any dignitaries of your institute be with you, you can give time to them also for some words of appreciation and thing. So I will call on first I'll call on Northern India Engineering College, Delhi. Professor Rajiv Sharma is there.
Yes, ma'am.
Good afternoon. How many participants you have?
In this particular program, we have 36 participants from 2 departments, Tripoli as well as from EC department. The total count is 36.
Okay, thank you.
And most of the times, our director sir, he actually wanted to be a part of this closing function, but unfortunately, he is not well today, so he did not come. So I take this opportunity, first of all, to thank you to make us a part of this event, and definitely in this particular event, we had the opportunity to interact as well as the lab sessions were also there. And we were also introduced with the SCILAB. And as you mentioned that SCILAB is definitely an alternative for institutes where the MATLAB is always an expensive affair. So it is an open source thing. So we can tell, as you told us, that we can tell our faculty members as well as our students to carry on this practice or working on an alternative availability and not to go for the pirated one.
Yes.
And so once again, I wish to thank you for giving us this opportunity.
Any feedback you want to give regarding the classes?
Yes, we have a number of faculty members here. First, I'll request Madam Archana to say a few words. Then it will be followed by a faculty from Tripoli department, and then one more faculty from EC department. Now I ask Archana ma'am to say a few words.
Yes. Okay.
Good afternoon, ma'am.
Yes.
I'm thankful for your SCILAB and other training program. It's very grateful for me and my department. Thanks, ma'am. It's okay.
Okay.
And as far as the learning part is concerned, ma'am, you've given us this SCILAB definitely with the passage of time, when will people along with the faculty and the students when they'll sit. So in the times to come, definitely we'll interact and we'll share our problems, because some of them have downloaded the software. The rest will follow. There are a number of faculty members who are teaching it as a curriculum.
Yes.
So as and when they'll actually when they'll sit on the machine and start working.
Yes.
So the problem will come, and in the sessions to come, we'll definitely share our problems and we'll share our experiences.
Yes. You can. And one more thing, I do conduct contact mode programs on SCILab and MATLAB. If some of you are really interested in working in that, you can come to our institute. Chandigarh is not very far from Delhi, so that they can have more knowledge of this. And maybe because it is a course on MATLAB and SCILab, we could not get much time to give you so much of input around regarding MATLAB, SCILab. So I have courses fully on SCILab also. So we can do that also in the coming days. In this year also you can look into, or next year also. If people you start working, you have problems, you can contact me. You can attend full week courses also on SCILab, because we will be doing it more, so that you will learn more of it. We will give you more project work which you can get done by the students. All those things we will be giving. Okay, because 2 days we have given only the basics of SCILab. Only two toolboxes, OpenCV and SCILab signal processing we have told you. We did not tell you much, so that also we can learn these days. Okay. Anything else?
Yes, as you have shared that we have a number of faculty members who are working on image processing and
yes.
So as and whenever you are conducting any programs, please share that information.
Yes.
So as and when possible, those faculty members will take this opportunity to come and learn more. Now I'll request a faculty from people department to share his experience with us.
Yes, yes.
Good afternoon, ma'am.
Good afternoon.
I'm now part from electrical engineering department.
Yes.
And it was really eager to know if we have alternative for MATLAB, namely SCILab, because many of our students face problem, and students normally use Python software, and we do not have any alternative. Now getting to know that there is an alternative, we will definitely implement in our labs. There's many labs on which for which MATLAB is basically very much important, and we entirely used to depend on MATLAB. Say for example,
yes,
Windows System Lab, artificial intelligence lab, advanced Windows System Lab.
Yes.
Now on these labs, now we can think of implementing those projects, those experiments on site.
Okay.
Obviously, we will start working on it, and I will ask to ma'am if we can get all the slides of.
Yes, I will send it. I will send that.
Okay.
MATLAB and I will send it. Okay, I'll do it.
Thank you.
Okay. Okay, then let me go to HMR Institute. Mr. Ravinder Beniwal. Hello. Hello.
Hello.
Okay, you can give some feedback regarding the course.
Good afternoon, ma'am.
Good afternoon.
Ma'am, course is very good for the faculties of electronics and AAA department, because we are also working in SCILab for the different subjects here in labs. In this embedded system lab is conducted in SCILab, digital system design is conducted in SCILab, and for AAA department, scientific computing lab and ACS lab are also conducted in SCILab. And we are have 2 or 3 labs that are in the SCILab. So we want a complete course on the SCILab for the next.
We can
and
do.
Also, the different faculties wants to share the contents of the all over.
Contents of the?
Contents of the SCILab and MATLAB course that you have conducted, the different PPT or other contacts that you
Okay, I will send the PPTs. I'll send it in your email ID, so that you can send it to the participants in your college.
Yes, ma'am, I will share my email.
How many participants you have?
Ma'am, minimum need about 70 participants were there.
Okay. One thing I wanted to tell you, anyone who want to give any feedback, somewhere else, some other participants want to give any feedback?
Ganesh.
Good afternoon, ma'am. I'm Prashant Bingham from EEE department.
Ma'am,
Yes.
actually, I'm working in image processing.
Yes.
So I have, if you can provide us the PPT in image processing on some video processing in SCILab. Actually, I'm doing my work in SCILab. So,
Actually, we had a lecture of OpenCV, computer vision processing, and in that he dealt with. I don't know whether you have attended it. It was on Tuesday. He gave it, but then because he's an expert from outside, it will be difficult for me to get those PPTs actually, because I don't ask those people, because they are all experts, may not be ready to share their PPTs. So it will be difficult for me to ask. Otherwise, we'll be doing again courses on this. I'll be calling again Mr. Dr. Gaurav, so that you can. He had given a very extensive lecture on OpenCV. Actually,
yeah.
OpenCV.
I have attended that class. I know that he has not yet given. Rest from what you have provided us the information regarding MATLAB and SCILab, that is very beneficial for me.
What is it?
And that is very beneficial for me, for my work.
Which one?
In SCILab, you have tell us about the video processing and image processing. In MATLAB also, you have teach us that, taught us that what we have to do like this, we have to do this programming and how we have to proceed further.
Yes.
So that is very beneficial for me. So thank you for providing.
Okay. I will give all my slides, PPTs. I will share with you. Okay.
Okay, ma'am. Okay, ma'am.
Okay, thank you.
Thank you, ma'am.
Then MSIT, Madam Shifali.
Thank you, ma'am, for this FDP. First of all, I would like to express my sincere thanks to you for accepting our request to this FDP and organizing it in a very short interval of time, and giving us opportunity to us and other colleges of GGS IPU.
Okay.
This 1 week workshop on MATLAB and SCILab has given a very good startup to the beginners and solved many problems of the faculty already working in this field. We would like to thank Dr. Gaurav Kumar for introducing SCILab and its installation in an easy and wonderful way. This task seems to be very difficult to us. Now he had given us so much introduction of it that we can easily install it.
Yes.
Then our heartiest congratulations to Dr. Simi for completing her PhD and then first lecture to us. We would like to thank her for giving us an in-depth knowledge about Simulink and genetic algorithm and solving specific problems of the faculty. She introduced interfacing with the hardware. That was very good, and I think it will be very helpful for our students as well. Then we will do it for students. We would also like to thank Dr. Mathri ma'am for introducing digital signal processing concepts and covering the basics and fundamentals in this domain.
Okay.
Once again, on behalf of Maharaja Surajmal Institute of Technology, I thank you, ma'am, for sharing your in-depth knowledge about this topic. We really appreciate your efforts, your punctuality, and art of giving lectures. Thank you, ma'am.
Thank you. Anybody else want to give any feedback regarding the program? Any improvement we want to make, we should make in the program?
Good afternoon, ma'am.
Good afternoon.
Ma'am, session on MATLAB and SCILab were very, very useful. And in fact, SCILab, since in our college, MATLAB is already installed in few computers, but we were actually planning to install SCILab also, because since it is freeware, so this workshop has been very, very useful for many of us, because SCILab, since we are about to start, so it has given a very good amount of understanding from your side. And one more thing I wanted to convey is that like, if we can, instead of covering so many topics in 5 days, if we can cover few topics in depth, it would be, grateful for us. Like in case of hardware interfacing, we covered a very little. And in fact, we covered very
we have a course, I'll tell you, we have a course on hardware interfacing alone. That will be in February. I don't know whether it is an ICT program. And if you have any doubts in hardware interfacing, in YouTube, Shimi ma'am's lectures are there. She had done a course on using through ICT also. That is also available. So you will get all those things, because we are doing, she had given only little bit on hardware interfacing during this program. We have a full course on hardware interfacing. Okay, you will be able to do it. You can be in contact with us. You will be able to. We will give you courses. Oh, no problem. No problem. We have. Okay, we have courses. See, sometimes what happens is we advertise our courses also during this time. We give you a little bit of it so that you get interested in it and you can attend our other courses. So you go to our website, look into electrical engineering department courses or look into the interdisciplinary courses also. And there our names are written as coordinators, Shimi, me, Vinny Matthew, Shimi SL, Ritula. So you can see those courses and then apply and come here also. Sometimes I feel that contact mode will be useful. Those who are really want to work in hardware and practical work, because we will be able to tutor you personally. During an ICT program, many a time we are fully our efforts cannot be shown here. So that is also there. Our laboratories are well equipped. We cannot bring your laboratory in front of the camera here. That is also into the studio here. So that is also a real problem for us. So you can come to our institute and see our facilities and learn also. See any short-term courses which in our list and then apply also. Okay. Okay then. And how many participants you have? Finally, 53 you have told me that day.
No, now it's 60. We have 60 participants.
Okay, thank you very much. Anyone else want to convey?
Nobody?
Okay.
Thank you, ma'am.
Thank you very much. Next is MESIET. Sonipat, Mr. Ravi. Good afternoon.
Good afternoon, ma'am.
Good afternoon. Good afternoon.
Ma'am, it was my first experience and I would like to express my sincere thanks to all of you, all the professors who teach us throughout these days. It's been very fantastic for us and it's very, very knowledgeable also. Thank you very much, ma'am.
Okay, thank you. Anybody else want to give any feedback among the participants?
Yes, Ms. Rekha, assistant professor from Electronics and Communication Department is also here. She wants to say something.
Yes. Yes. Good afternoon. Good afternoon. I cannot hear you a little bit louder. Okay. Okay, I cannot. Hello? Hello? You are not audible. Are you speaking? Hello? It's not audible properly. I just wanted to tell you. You come near the laptop and speak. नहीं खत्म है लास्ट है एक और बार करो वो MBSIT एक और बार करो हो गया ये सब बात हो गई हाँ वही वो है ना दूसरा ना हाँ okay. We will connect MBSIT again. I could not hear what happened, what she was telling. 1, 2, 3 announcements I want to make. I told you on the first day itself to mark. I asked the participants to mark their attendance of each day. Hope it would have been finished by now. So the coordinators has to send me all those attendance sheets. Then a feedback form is there. Those who are regularly means being our senders have it. I think Mr. Ravi was telling this is his first experience. If they don't have the feedback form copy, I can send it to you. Anyway, I'll send it to all of you. So get those feedback forms filled and send me that also. Then one more thing I want to tell you is we have an Excel sheet format in which you have to send the names of your participants typed in. Then from there, we will be printing the certificates. So one thing I wanted to tell you is the participant should care, the coordinator should carefully see the names of the participants. Many a time it happens that the coordinator send the Excel sheet, and then when we send the certificate, they call us and tell, ma'am, ye galat ho gaya, wo galat ho gaya. So dubara for certificates issue karna will be very difficult for us. So because your certificates are also in good number, 60, 50 and all. So the coordinators be very careful in checking the names, spellings of each of the names of the participants and the other details which you fill in that. There should not be any mistakes in it, and then send the Excel sheet. Actually, we have a program in such a way that these Excel sheets are directly given, and we print the certificates out of it. Then regarding the bills, because all of you are private colleges, you will get only 4,000 rupees, 2,500 for the coordinators and 1,500 for technical staff, auxiliary staff. So what you do is you send the vouchers and the details, bank details of the person to whom we should send the money, because nowadays cash or check is completely stopped. We will be sending through to your account. So account number, bank and IFSC codes, that also should be sent along with the vouchers. On that voucher itself, you have to write that so that the money will be transferred to that account only. Okay, so once more, let me try MVSIT. Whether MVSIT is online? Disconnect ho gaya. Okay, you are disconnected. So I thank all of you for the patient listening, and the 5 days program was really an encouragement for me also. Madam Shifali only requested me to do this course. This course was not in my usual program. For that, I have to work a little bit hard when a course comes all on a sudden. But then even then I could plan it properly and do it, and I could have the cooperation of all of you, and I congratulate all of you, and I find that you people were attending the classes also, and I'm happy that you have downloaded SCILAB, practiced it, planning to do it. I'm happy hearing your feedback also. So thank you so much. We will again be in contact. You have your you have my email IDs, you have my telephone numbers, so you can call me if you have any doubts while you work on SCILAB or MATLAB. Thank you very much. See you again. Okay, thank you so much.